Okay, guys, what we're going to look at today, we're going to look at a summary of normal distributions. So basically what I'm going to do is I'm just going to walk through some examples with you and show you how we would calculate all of these, how we would come up with these. So if you look at question number 1, cholesterol levels of adult American women can be described by a normal distribution with a mean of 188 and a standard deviation of 24. So what we want to look at for part A, what proportion of adult women has a cholesterol level above 200? Now this is one that we can do in our calculator, and the function that we're going to use for this is the normal CDF key. Okay, so normal CDF. Now, normal CDF has 4 parameters that you need to put into the calculator. You need to put your lower limit, you need to put an upper limit, you need to put your mean, and your standard deviation. So if we think about what we have, the easiest ones, we know the mean and we know the standard deviation. So those are going to get filled in pretty easily. Now, for the lower and upper limits, we have to think about what our question is asking. Our question says, what proportion of American women has cholesterol level above 200? So that means we're using 200 as our lower limit. We want only 200 and above. So then we want to do E99, and that's going to represent our positive infinity. So if we open up our calculator, the VARS key, VARS, we're going to do second, and then that's going to bring up the distribution menu. And the second option that you're going to see is the normal CDF. So when we select that, now some of the calculators may be different. This one, it actually asks me specifically for my parameters. So I would fill in 200, I would fill in E99, then it asks for my mean and my standard deviation. And it's going to go ahead and fill those things in for me. Now, if you do not have one of the newer ones, if you have a just a normal TI-83, or if you have a TI-84 but not the plus C, what it's going to do is it's just going to bring up normal CDF on your screen, and you would just need to type those in separated by commas. So then when we hit enter, it's going to calculate that for us, and we get, let me bring my paper back up. We get 0.309, which we can then say approximately 30.9% of American women has a cholesterol level above 200. Okay? Now, part B. Above what values are the highest 15% of women's cholesterol levels? So, they're giving us a percent, and we want to know what cholesterol level is associated with that percent. So we want to know above what value are the highest 15%. So in this case, you're going to use the function inverse norm. Now what inverse norm asks for, it has 3 parameters. Okay, and the last 2, once again, are your mean and standard deviation. Now, the way inverse norm works, what it asks for in that first parameter is it wants to know the percentage below, okay? So if we're looking for the highest 15%, then below that, we're going to have 85%. So we're going to have to put in 0.85. So when I go back to my calculator, I'm going to do second distribution again, and I'm looking for inverse norm, which is the third option. Now, it calls it area, so because you have to think of it, let me get my paper here, you have to think of it like we have our normal distribution, it's going to ask for an area. If this is our 15% cutoff, okay, we want to know what value is here. So what they're asking for is we want to know the area below that, and they're going to give us the cutoff value. So that area, we have 0.85, mean of 188, standard deviation of 24. I'm going to paste that into my inverse norm, and it's going to calculate. So that means above what value? That means the highest 15% have a cholesterol value above 212, and we'll say 0.9. So 212.9. Question C. What is the percentile for an adult woman with a cholesterol level of 175? Now, this one is actually pretty much the same type of question as A. It's just worded a little differently. A asks what proportion of adult American women has a cholesterol above 200. We're asking what percent, let's see, what is the percentile for a woman with cholesterol level of 175? So what we're going to do is, again, we're going to use the normal CDF. Now we want to know at 175, so we're not looking for above 175. We want to find what is the percentage at that point. So we're going to do negative E99. 175 is our cutoff. 188 is our mean. 24 is our standard deviation. So that's what we're going to type into our calculator. So second distribution, normal CDF. I've got my negative infinity. Then I'm going to 175, mean 188, standard deviation 24. So I see it's 0.294. So what that tells me then is the percentage, 29.4. Okay. Part D. Between what two cholesterol values does the middle 80% fall? Okay. Now this one, we're kind of using what we did in B. Okay, we want to use the inverse norm because that's what actually gives us a cutoff value. Now, what we're trying to do here is we are trying to look at the middle 80%. So that means from 10% to 90%. And we want to know what's the cutoff value here and here. So what we want to do, we want to see two different values. So that means we're actually going to set up inverse norm twice, one for the lower portion and then one for the upper portion. So for our first one, and remember we're always looking for the area to the left, so my area to the left of 10% would be 0.10, mean 188, standard deviation 24. Then I need to do a second one, and I want to know what this cutoff value is. So to the left of that, 0.90, mean 188, standard deviation 24. So I'm going to do both of these in my calculator. Second distribution, inverse norm. First one, 0.10, mean 188, standard deviation. So my minimum value there, 157.2. Then I need to do this again. But now my area is 0.9. So my upper limit is 218. So the middle 80% are going to fall between 157 and 218. So let's see. What was it? 157.2 and 218.8. Number 2, an incoming freshman took her college placement exams in French and mathematics. In French, she scored 82. In mathematics, she scored 86. The mean and standard deviation for the French exams were 72 and 8, respectively. The mean and standard deviation for the math exams were, 68 and 12, respectively. On which exam did she score better when compared with the other freshmen? Okay, so for this one, let me grab a piece of paper here. We've got some information about her French exam and her math exam. So her score on the French exam was 82. The mean is 72. Standard deviation is 8. Her score on the math exam was 86. Mean was 68. Standard deviation was 12. Now, the easiest way to compare these two scores and to see which one she actually scored better when compared to the population, we want to know her z-scores. We're going to look at the z-scores and compare those, because your z-score gives you it tells you how many standard deviations you are away from the mean. Okay, so the farther she is above the mean, the more standard deviations she is away from the mean, obviously the better she did. So when we look at the z-score for French, to calculate a z-score, and I'll just put this up here, we do x minus the mean over the standard deviation. So, oh my, apparently something's got my dog all out of whack. So let's see, 82 minus 72 over 8. She's not happy about something. And just a quick calculation of that, I get 1.25. Now, my z-scores for math. If we do 86 minus 68 over the standard deviation, we get 1.5. So, what this tells us is she scored better in math compared to the other freshmen because she was 1.5 standard deviations above the mean. So, let's see now. Number 3. What proportion of z-scores are between negative 1.5 and positive 1.5? Okay, so let me go back to my paper here. We want to know z-scores between negative 1.50 and positive 1.50. We want to know what proportion of scores are between those. Now, this tells you, like I said, z-scores tell you how far you are above and below the mean. So if this is our mean, down here, negative 1.5 away, positive 1.5 away. And we want to know what proportion of scores are between these. Now, if we use our, let me find mine, our z-score table. There we go. If we use our z-score table, let me just try to zoom in on this a little bit. And I'll focus. Okay, at negative 1.50, which is right here, we have negative 1.5 and 0.00. So that's going to be this value. So 0.068, 0.0668, sorry. Then we're going to look at positive 1.50, and that's this value, so 0.9332. These are the values that correspond with our curve here. So what this tells me is 93.32% fall below this value. But I know that below this one, it was 6.68. So I'm looking for the area between those. So 93.32 minus 6.68 gives me 86.64%. Okay, 86.64%. All right, now question 4. The standard deviation of a normal distribution is known to be 7.5. However, the value of the mean is unknown. It is known that a score of 60 represents the 45th percentile. What is the mean? So think about what we already know. We know the standard deviation. We do not know the mean. We know that a value or a score of 60, this represents the 45th percentile. Now, if you think about what all this means, okay? Mean, standard deviation, these are all values that are used in calculating z-scores. And a percentile is related to a z-score also. So if we want to find the corresponding z-score for the 45th percentile. So if I go on here, I'm looking for the 45th percentile. So what I'm going to look for then is 0.45, and I want to try to get as close to that as possible. So 0.45, as close as I can get. Let's see, which one of these is it going to be? This one, I believe. Okay, is going to be closer to 0.45. Now, this z-score, or this percentile, has a z-score of negative 0.13. So, I know now that my z-score is negative 0.13. So, what I'm going to do then is I know the z-score formula also. Z is equal to x minus the mean divided by standard deviation. So negative 0.13 equals x, oops, we know what x is, 60 minus the mean over the standard deviation. Now I can multiply both sides by 7.5. So that gives me negative 0.975 equals 60 minus mu. Subtract 60 on each side. And divide by negative 1. So I know the mean is 60.975. Okay? Now, really, that should be pretty close because if you think about it, the 45th percentile, where is that going to fall on your distribution? If dead center is your mean, 45th percentile, we're just a little bit off from our mean. Okay, so it kind of makes sense that we should be that close to our mean. And our mean, if our score was 60, the mean is 60.9. So we are just a little bit off from our mean, so just a little bit less. So there you have it, some normal distribution problems. Let's see, I think that's it.